Hello everyone. So we'll continue with our previous lecture. So we'll be discussing your context-free grammars, where we are discussing various problems of writing context-free grammar for various languages, and we were at this question: a raised to power n, b raised to power m, where n is not equal to m. See, we have said that the requirement of this language is that all a must come first and then all b's, and the number of a must not be equal to number of b. So there can be, I said, two cases. One is that your n is greater than m. Okay, n is greater than m, and second case is that your n is less than m, right? So let's suppose in first case I call it language 1 and I call it language 2 in second case. In first language L1, number of a is greater than number of b. In second language, number of a is less than number of b. So my language contains what? My language L is actually union of these two languages, L1 union L2. See, any string is valid string in my language L if number of a is not equal to number of b. That is, either number of a is greater than b number of b, or number of b is greater than number of a, right? So how this? So first we try to write down the grammar for L1, then for L2, right? And once if I have the grammar for L1 and L2 independently, then I can simply use the union of these two, right? Because the context-free languages are closed under your union operation, right? Now consider this. We said that if n is not equal to m, then it is either n greater than m. N means your number of a is greater than number of b. Now consider this, that this part is number of a is always greater than m. Now see this, S1 is the start symbol for this language L1. Let's suppose this is your language L1. S1 is the start symbol. So whenever you drive a string using the grammar, we always start from the start symbol. So start symbol for this is S1. We always has a in the beginning. Now what this first a is doing, it is generating any number of a, at least one a, and then any number of a, right? This first a, what this a is doing, it is generating one or more number of a's independently, right? And this S2, what it is doing is, it is, see here, it is generating equal number of a and b, right? It is generating equal number of a and b, or it can be empty also. So in our case, we said that L1 is where number of a is greater than number of b. So this a is generating only a, at least one a is always there. So at least one a is generated by this a, or one or more a from this, right? And S2 will generate equal number of a and b. So obviously the number of a in any string which is generated by these grammar rules will be more, right? And second case can be the number of a is less. So in this case, we have S3 is the start symbol for this grammar. Let me call this L2. L2 is the grammar where the number of b is more as compared to number of a, and S3 is the start symbol for this. Now if we always start from the start symbol, S3 in this case, and see we have this b in the end, and this b will generate one or more number of b's. This b which comes from the start symbol, we have only one production from the start symbol where we will start. So S4 and b, and this b will generate at least one or more b's, right? And this S4 will generate equal number of b, right? So this S4 you can terminate using a empty string also, and then any number of a and b, but equal number of a and number of b will be same, the string generated by S4, followed by one or more number of b. So previously this will generate equal number of a and b, and finally b will generate one or more b. So obviously the number of b in this part is more, right? So now I combine these two, into a third grammar, which is L, and L is L1 union L2. See, S is the new start symbol for language L. S drives either S1 means start symbol of this and start symbol of this second language, S1 or S3. String can be generated either this start symbol or this. Either it is in the language S1 or in the language L1 or in the language L2, right? and where S1 is for start symbol from this L1, S3 start symbol from this L2, right? Now consider this, when you if you choose S drives S1, then you will generate a string where number of A is more. If you start from S3, you will generate a string where the number of B is more. See this? If you generate a string from S3 where the number of B is more, right? So, and you can combine these two. So, and one rule is common in both the case, which is this S4 and S2. So, we'll keep S2 and avoid F4 because of the redundancy, right? Or if you are comfortable in writing grammars, you understand many, you will solve many problems, then you will realize that this grammar is also generating the same A. See, from A you are generating equal number of A and B, right? But this A will be either terminating in A, capital A, this S is either terminated in capital A or capital B. If you terminate it with capital A, then you have more number of A. If you have B, then you have more number of B's. So these two solutions are equivalent, right? These two solutions are equivalent, right? Okay, so let's move to the next problem. So it is simple, right? We have A raised to power n, B raised to power 2n means and n is greater than equal to 0. So the smallest string can be, if n is equal to 0, then no symbol at all. So S drives your empty string, right? If n is equal to 1, then the smallest string will be n is equal to 1. If it is A, then we have 2 B's, right? If, and obviously all A first and then all B, and number of B is double the number of A. So whenever a single A comes, there must be twice the number of B has. So we have S drives, see this A, B, B, this is the smallest string, and in between we have S, so that this S can be repeated with A, B, B, A, B, B any number of times, and you want to terminate, then you can terminate with empty string, right? So okay, so this is the grammar for this. Then again it is a similar question, so I guess you will be comfortable in solving this, where see, the question here is that there is no relation between this number of A and number of B. The only thing is that A is a multiple of 2 and there is no question about number of B's. See, so the smallest string will be that at least 2A, right? Because number of A, n is always greater than 0, so it is minimum value for n is 1, so no, at least 2A is always there. So see this, starting from the start symbol, 2A are always there, right? And then this A will generate number of A in multiple of 2. This capital A, see this, generate A in multiple of 2, right? And you can always terminate this with empty string. And this B is, it can be empty, it can be 0 or more number of B. So see this part, you can generate 0 or more number of B using this rule. So okay, so this is the grammar for A raised to power 2 and B raised to power m. Now consider this problem where A and B must be equal, right? And C can be any number greater than or equal to 1. See this, again we know how to generate A raised to power n, B raised to power n, and this is it. For A generating equal number of A and B, right? A generating equal number of A and B. And then this for C, one or more number of C, we have this rule. So finally, this is, see, we have actually two languages. This is language L1 and this is language L2, and these two languages are concatenated. So now here we have, this is language L1 where A and B are equal, and this is language L2 where one or more number of C. And then finally we have this language which is L is equal to, which is L1 dot L2, right? Concatenation, right? Okay, done. Then we have this A raised to power n. See here, this number of A and number of B must be equal, and in between there is at least one C. Okay, in between there is at least one C, and n is both n and m greater than. So again we know how to generate A and B, equal number of A and B. So this will generate equal number of A and B. And when I want to terminate this S, then I'll replace this middle s with another variable a, so that because in between now I need some number of c's, at least one c. So if it is exactly one c, I'll replace a with single c, or more than one c, then I replace this ca. So you remember the earlier question we have discussed that this is actually c plus, this is actually c plus, positive closure of c, we'll do it like this. So if we c star, then it is a drives small c capital a drives small c capital A, or your empty. So this is your c clean closure of c, right? Okay, then next is your see, here we have this number of a and b must be equal, number of c and d must be equal, and n, m, m both are equal. This is easy one, right? So we have again two languages, one is this s1, one is this l2, l1 and l2, sorry. So L1 is equal number of A and B. We know how to generate. See this, L1 equal number of A and B, and this B is similarly equal number of C and D, and then we are concatenating with the start symbol, that S drives A and B, A followed by B. First equal number of A generate equal number of A and B, and then B generate equal number of C and D. Hence, okay. Then we have, now see this. Construct context-free grammar for 0 raised to power I, 1 raised to power j, 2 raised to power k, where either I is equal to j or j is equal to k over this alphabet 0, 1 and 2. Now see, consider this, if I and j is equal, if I and j is equal, then see this, we said this is another language. When I and equal to j and when j is equal to k, it is another language. Let's suppose this is some language L1 and this is some language L2. So I'll write grammar for these two differently. Let's suppose S1 drives AB, where this S A capital A drives equal number of A and B, because in first case we have equal number of 0 and 1, equal number of 0 and 1. So this A drives equal number of 0 and 1, including the empty string also, right? Because I is equal to j. If no a 0 is present, then no 1 is present, right? And then this B, it will generate some number of twos, right? It will generate some number of twos. It can be 0 number of 2, 1 number of 2, or more number of 2, and then we concatenate it, that A followed by B. A generate equal number of 0, 1 followed by B generate some number of 2's. Okay, so this is for language 1. Similarly for language L2, we have S2 drives C and D, where this D drives equal number of 1 and 2, because in this case we need j is equal to k, means number of 1 is equal to number of 2. So whenever there is 1, there is a matching 2. Okay, so D will generate equal number of 1 and 2, and this C in the beginning will generate some number of zeros. It can be 0, it can be 1. So my string is valid in my language L if either I is equal to j or j is equal to k, in any case. So I have a start symbol S which says S drives S1 or S2, means if a string is derivable from S1, then also it belongs to this L, or if it is derivable from S2, still it belongs to this L, right? So this is you must understand this clearly. Now consider this question. Now A raised to power I and B raised to power j. Now consider this, that see this again, A B, oh no, this is something wrong with this. This is not all over A, this is simply A comma B, right? So clearly this answer is given, that if I is 1, if I is number of j is less than equal to 2i, means number of j is at maximum it is 2 into multiple of number of a, means and I is equal to at least 1. So if I is equal to 1, then number of a, this is the string, either 2 or it can be the string a and b, right, less than or equal to this, right? So it is j is between I and 2i. So if it is equal, then we will use this, right? If it is exactly multiple, then we will use this, ठीक है. And for terminating this we have AB because this is the smallest string, and ABB, this is the second smallest string when the J is in multiple of I, right? So this is another one. Now this is again a regular language because we have a regular expression for this. We already discussed how to design a grammar for A plus B clean closure, means any string over A comma B, right? And see this X, this part is actually, this X is actually generating this A plus B clean closure. See, from S we can generate A, again this X can be replaced with B, and again this X can be replaced with anything. I mean any string over A comma B can be generated from this X. And because now in this particular case we have a any string over A comma B followed by triple B compulsory and then again X. So again we have X, triple B and X. Now this X can be can leads to empty. So the smallest string in this language is only triple B because this is a clean closure, it will contain empty string. This is also clean closure, it can contain empty string. So the smallest string which this language has is triple B, so which we can easily generate because S drives X, B, 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 X, and this X can be replaced with this empty, and hence okay. Now see this is A raised to power I, A raised to power I, B raised to power J, and C raised to power K. I is not equal to J or J is not equal to K over alphabet A comma B, right? Or in other words you can say set of all those strings of A followed by B followed by C such that this is nothing, such that there are either different number of A and B or different number of B and C. You understand what I'm saying? See, this is similar to our previous question where just like this, in this particular case we are saying that either I is equal to J or J is equal to K. But now here what we are saying is that either J is not equal to I is not equal to J or J is not equal to K. So similarly, on a similar manner you can solve this question also, right? So this is for your practice, right? Then we have this is again a simpler one. It simply says that A raised to power n. See, these two things are need to be same, right? And these two need to be same. So whenever we generate A, we generate a corresponding D. See here, whenever we generate A, we generate a corresponding D. And when we generated enough number of A and enough same number of D, then finally this S will be replaced with capital A, and capital A will generate this middle part. Middle part is equal number of B and C. See this, A is generating equal number of B and C, and where, because this N and M are greater than 1, so A is generating at least one BC and S is generating at least one this, right? The smallest string in this particular case will be A, B, C and D. This is the smallest string in this case, right? So this is a simpler one. So consider this again. So A raised to power m plus n. You see this, A raised to power m plus 1 and m number of B's followed by m number of C. So two things, that number of A is equal to number of B plus number of C, and all A first, then all B, and then all C, right? So this can be rewritten as like this. See this, A raised to power n, and so now these two are same and then these two are same. Now if you write like this, then it is quite easy to understand because we have already solved problems like this, that first we have A and C matching and then A and B matching, right? A and C matching, and then we have A and B matching, right? So this is quite simpler one. Now consider this is of again of same type. So again you just simply rewrite this in this format, and then first it I mean same number of this must be B, this must be B, okay? B raised to power n, A raised to power n, B raised to power n, B raised to power m, and C raised to power n. So first we write equal number of A and B concatenated by equal number of B and C. So here we have A which will generate equal number of A and B, and then we have B which generate equal number of B and C, right? So again, Now consider this. In this particular case, see, understand this problem. The language contains, it says n is greater than equal to 0, m is greater than equal to 0, k is greater than equal to 0 over this alphabet a comma b, right? So means the smallest string in this language L, smallest string in this language L can be your empty string null. Okay, so is null is generated, see, s drives x y, x can be replaced with null, y can be replaced with null. So okay, so null is generated. The next smallest string can be that there is no 0, no a, and no b. Means there, the only problem with this language is that number of a and b must be equal, right? One thing. And second thing is that number of c is bounded by this value 3. It can be maximum 3, 0 number of c, 1 number of c, 2 number of c, and 3 number of c, not more than that. So we have two things actually. One is s drive x, x generate equal number of a and b, s generate equal number of a and b including the empty string, followed by y. Y generates what? Y generates a single c, double c, triple c, or empty, because value of c, k is bounded by 3. K means number of c is either less than or equal to what? 3, right? Less than or equal to 3. So if it has 1c, 2c, 3c, otherwise if c more than 1c, any string having 4c cannot be generated using these grammatical rules, right? So any queries, you can contact me, right? Okay, thank you.